motion. Okay, in other words, they are giving us the distance formula, exactly what we just had in the previous two problems. Some f of t. Of course, t is measured in seconds and s in feet, but I wanted to say, of course, it's greater than or equal to 0. It's time. Find the velocity, find when the particle is at rest, find when it's moving in the positive direction, and we're going to determine both, when it's moving in positive direction and negative direction as well. Find the total distance traveled by the particle during the first 6 seconds. Draw a diagram, we'll deal with that later. Find the acceleration at time t and after 1 second. This is with the graphing calculator, we'll do it, of course. And when is the particle speeding up and when is the particle slowing down? So I know it's a long problem. What did I do? No, I don't want any flashcards. No flashcards. Okay. Okay, so we have several situations here, and let's choose one. Maybe we should start with number 1. They're all different functions, but they all apply the same steps. Okay, I am on page 12. Okay, so we have f of t, and that is t to the third minus 9t squared plus 24t. And let's start with velocity v of t, and after 1 second, and when is the particle at rest? So we have 3 questions so far. Time t, the velocity at 1, and when is the particle at rest? Okay, so part A, v of t. Can anyone dictate v of t?
So 3t.
Yes?
3t minus 9t plus 24.
3t squared, right? Okay, maybe you said it, I didn't hear it. Good. So in part 2, they want v of 1. So 3 minus 18, negative 15, plus 24, and we get 9. 9 what? Nine what?
Second.
The rate of change, velocity, has 2 measurement units. Any rate of change has 2 measurement units. There is no rate of change that has only 1. Feet per second. Yes, feet per second. Good.
So whenever it asks us for the velocity, you find a derivative?
The velocity is the rate of change of distance with respect to time.
Okay.
When I drive somewhere and somebody calls me and says, what is your speed? I look at the odometer and I say 49 miles per hour. The rate of change of distance with respect to time changes with 49 miles per hour. When is the particle at rest? Part C. What does that mean? Particle at rest. When is your car in the parking lot? What does it do? What is the speed of the car if it's waiting for you?
It's 0.
Yes.
The particle's at rest.
Yes. V of t is 0. Correct. Perfect. So here's v of t. 3t squared minus 18t plus 24 equals 0. What can we do here to simplify it? Which I did not say in the previous situations because the numbers were so weird that there was no point in even discussing that. But here I can. Can we simplify this in any way?
We can factor it.
We don't factor equations unless we factor out variables. But if we get rid of numbers, we do not factor. We are dividing both sides by 3. So we get t squared minus 6t plus 8 equals 0. We should be able to quickly determine this, or you can use the feature in the calculator. But this should not be a problem. What do we get?
T minus 4, T minus 2.
So then we have t equals 2 seconds and t equals 4 seconds. Perfect. So the particle is at rest at 2 and at 4. Okay, perfect. Okay, moving on. When is the particle moving in the positive direction? I'm adding here also negative direction. Positive, negative direction. Okay, so we are going to study the sign of the velocity because we already discussed in the previous examples that when the velocity is positive, the particle is going up. When the velocity is negative, the particle is going down. So it's going in positive direction and in negative direction. And we already know, I'm going to add something here that, and I will come back to the table. I want the entire table to be together. So you don't have to, just leave some room underneath if you're copying this right now. Leave some room because I need to add that in. So we are told that t is greater than or equal to 0. And we know that at 2 and 4, the velocity is 0. So here is the velocity function. And in this expression, I know that that expression is 0 at 2 and 4. I know that it has a minimum, right? If you were to graph that, you will have this. I need the sign here, the sign here, and the sign here. Here's another way. You can say, but that's complicated. Fine. Let me show something. Let's put it in the graphing calculator. So in y equals, clear whatever, and let's plug in our velocity function, 3t squared, and then minus 18t, and then plus 24. And all I want now is to choose a number to the left of 2, a number between 2 and 4, and a number to the right of 4. Please give me a number to the left of 2, but not lower than 0. A number to the left of 2, but not lower than 0. 1. Perfect. Awesome. So it's positive. A number between 2 and 3, not between 2 and 4, not 2 and not 4.
3.
Good. Awesome. So it's negative. And a number greater than 4, not 4.
5.
Oh, good. As expected, positive, negative, positive. Positive, negative, positive. So can anyone tell us when is the particle going in the positive direction? Between 0 and 2 seconds, and also between 4 and infinity. Positive direction between 0 and 2, positive direction between 4 and infinity. When is the particle going in the negative direction? Coming back, in other words, if you want.
Between 2 and 4.
Between 2 and 4. Awesome. Excellent. Stop me if you have questions, please. Back to the book. Find the total distance traveled during the first 6 seconds. Fine. So I don't really care for infinity. I really need 6 seconds. Infinity is in parentheses. It doesn't matter. It does the same thing. So here's what happens to find the total distance. For the first 2 seconds, the particle, first second, second, it goes this way. Then it comes back 4. 1, 2, 3, 4 seconds. And then turns around and goes 1, 2 seconds till 4. So between 0 and 2, between 2 and 4, and between 4 and 6. So the particle goes this way 2 seconds, then goes this way 4 seconds, and then it goes this way 2 more. Between 0 and 2, between 2 and 4. Oh, I went too far. So between 0 and 2, and then he goes between 2 and 4, he goes, okay, so my graph is not good. So 2 seconds this way, and then 2 seconds this way, and then 2 seconds this way. So what does this mean? It means that I have to add the distance between 0 and 2. I have to add the distance between 2 and 4. And I have to add the distance between 4 and 6. It doesn't matter if I go from home to school and back, my odometer will add the distance. It's not going to subtract if I go back, right? So the distance covered between 0 and 2 plus the distance covered between the second 2 and second 4 plus the distance covered between 4 and 6. But I have to be careful because I need to add positive values. So f of 2 minus f of 0 is the distance, f of 2 minus f of 0 is the distance between time 0 and time 2. The distance between 2 and 4 will be f of 4 minus f of 2. F of 4 minus f of 2. And here, f of 6 minus f of 4. I'm going to write it one more time because it's not clear there. I just needed to explain it first. And I don't want to confuse you with this. I only needed to go back 2 seconds, not 4. So I'm going to erase it from here completely because I explained on the next page. But again, my hope is that my students will look at this and practice. So I need it to be accurate. Okay, so then the total distance will be f of 2 minus f of 0, the absolute value, plus the absolute value of f of 4, I meant minus, of course, minus f of 2, and finally plus the absolute value of f of 6 minus f of 4, and close. You can say it's fine to have the absolute value on this because it goes in the negative direction. But really, there is no need for you to use the absolute value because it's going the positive direction here and here. I agree. So I'm just going to give you the heads up that these can be omitted because for those between 0 and 2 and between 4 and 6, the particle goes in the positive direction. So these are not required. But for consistency and uniformity, this is what we should always do. But here, this is absolutely necessary. But I need to find these values. I have the function in the graphing calculator waiting for me. Here it is. So that's the 3. No, I don't have it. I'm going to put it in. I have t cubed. That's a distance. I need a distance. Minus 9t squared. And then plus 24t. I need a distance, not a velocity. And I'm going to de-highlight this because I don't care for it at this moment. Okay, so I go and quickly determine the values for 0, 2, 4, and 6, and just simply copy them in the particular order I have them here. So f of 2, 20, minus f of 0, 0, plus f of 4, 16, minus f of 2, 20, plus f of 6, 36, minus f of 4, 16. So 20 minus 0, 16 minus 20, and 36 minus 16. The distance must be positive. We can never have a negative distance. So 20 minus 0 is 20 in absolute value, 20. 16 minus 20 is negative 4 in absolute value, 4. And 36 minus 16 is 20. So 20 plus 20 plus 4 is 44 meters. I think it was feet. Yeah. So this is the total distance. Even if you say, but the absolute value was necessary only, it's better to put it for each distance. Any questions on this? Find the total distance. The diagram is what you just saw, going in one direction and coming back and then going back. Find the acceleration at time t and also after 1 second. I warned you that this is a long problem. So this is the velocity. They're asking us to find the acceleration and the acceleration after 1 second. So this was g. How do I find a of t?
Is the prime of
Yes.
the velocity?
Yes.
Or it's the original equation?
The double prime of the original, yes. So how do I differentiate this?
So it'll be 6t
Yes,
minus 8.
minus 18. Perfect. So now they want us to find a of 1. Of course, it's 6 minus 18, which is negative 12. Again, this means direction. No negative acceleration. But what is the measurement unit? And you can no longer say feet per second because this is already taken by velocity. It cannot be the same measurement unit.
6 feet per second squared.
Excellent. Indeed, feet per second squared. Awesome. Okay, and now let's go back. Graph, we can put those in the calculator. Final step. When is the particle speeding up? When it is slowing down? That's the last part that we need to look at. Okay. So here's some analysis before we answer that part. Let's say I ride my bike. That's me riding my bike with a velocity v1. And I have, coming from the same direction, I have wind v2. So the wind is pushing me. It's helping my speed. What will be the combined speed, my actual speed, actual, or combined speed? What will be my actual speed? Or you are going on a plane and there is a tailwind. What will be the combined speed, the actual speed of the plane? Anyone?
It's going to be the addition of
Yes,
both?
absolutely. Excellent. What if now you're on a plane with a speed of v1, but there is a headwind of speed v2? So what will be the actual?
The difference.
Yes, it will be v1 minus v2. So please keep that in mind. If two forces are helping each other, or when two forces are against each other. Okay? So, in order to determine when the particle is speeded, I think I have to start a new